Here we are in 9.7. You guys have had some time to take notes, and so we're going to pick it up and then kind of just bust our way through the rest of notes. But first, really quickly, before we talk about the rest of notes, there was one example that we didn't get to finish last time. Maybe just a few of you didn't even finish these notes. If you pulled up the Jamboard, of course, you could have gone back and written down whatever you needed to. But there was one example that we didn't get to do. So we're going to talk about that one real fast and then move on to the other two ideas. If you guys want, you can totally write it after the notes that you just put down. Or you can just kind of pay attention and, I don't know, hope that it sticks. That's a little dangerous. But here we go. A random number generator on a computer selects how many integers? 3 from what range of numbers? 1 to 20. And what do they tell me, or what are they asking me? What is the probability that what?
All 3 are less than or equal to 5.
Okay, so all 3 are less than or equal to 5. Probability says I need a percentage, and a percentage is really a decimal, and a decimal can come from a fraction. Review in your notes from last time. P of E, probability of an event. P of E, a probability of an event. Yes, good. Equals what?
E or N of E over N of E.
Careful, no. N of E is the number of ways a special event can happen over N of what? The number of, or in the sample space. So I have favorable over total. Does that make sense? Favorable over total.
My S looks like
Oh, struggle bus. Fix that, fix that. Now, hold on. What would be favorable? What would be favorable? That all 3 of the numbers are less than or equal to 5. Good. All 3 of the numbers are less than or equal to 5. So there are a few different ways of writing this down. Question though, what do you guys think? Do you think this would be a permutation or a combination? Because we have 20 numbers. We're choosing 3 of them. We're trying to figure out the probability that all 3 numbers are less than or equal to 5.
Combination.
Combination?
Yeah, because it doesn't matter like the order of the numbers in which equal 5, as long as they just equal to 5. Or less than.
So let's test it out. If we go ahead and use the NCR route, we could say that we have 20 numbers and we're choosing 3. Do you guys agree? 1 through 20, 20 different numbers, picking 3 of them. Okay. And then on top, wait a minute, what's the special case? We're saying all 3 numbers come from what special range of numbers? Less than or equal to 5? How many numbers are less than or equal to 5? 5. Okay. I want you guys to plug this in using your very nifty calculator functions that we talked about at the end of last week. I'm just curious, are they the same or are they different? One of them is trying to figure out the ratio of all the different arrangements. The other one is talking about the ratio of all the different combinations. Let's just see. Maybe if you kept them both combination, maybe if you kept them both permutation, it'd be the exact same thing. Maybe it wouldn't be. As you're pulling up your calculator, remind me of how or where we go to find all these things. What menu is this? Math and then prob, right? And everybody can go there, whether or not your calculator has all the cool updates. Remember just that math and then over to prob. If your calculator is a little bit older, when you hit this combination, you're not going to have this nice little spot, but you can still type in that beginning number and then hit in the NCR and then that ending number. It'll still work like we talked about last week. Ah, interesting. Why would they be the same thing?
maybe like applies in both situations.
Yep.
I'm not sure if this would work. I'm trying just to, oh no, I don't think it will. I was trying just to change the combination. I don't think that'll work. But you guys did it for permutation as well. I guess for those people who aren't in here in class and might not have a chance to reach out. Let me just remind them once again where I'm getting all this information from. That math, that probability. I had all the kids plugging in both just to see. Okay. I want you guys to see that usually combinations and permutations are counting differently, but when you bring in probability, Ryan, as you said, like the order didn't really matter, right? So if we just think about how many combinations would fill, like how many combos of numbers would fulfill this event out of the total number of combinations, we will get the same ratio as what if we were to think about it in, because I was thinking like actually the order would make a new option as far as like what if there was a 3 and then a 5 and then a 7, which would be a different computer generated than a 7 and a 5 and a 3. But if I make my denominator permutations also, however many more arrangements are here would be mimicked down here. And so the ratio ends up being the exact same because I'm counting them as though it doesn't matter, or I'm counting them as though it does matter, but still that ratio of how many will be exactly the same. Now, hold on. How good or bad would it be though if I like had a combination on top and a permutation on bottom? Is that going to work? No. I do need to make sure, kind of like in all of math, I want everything to, yeah, be in similar terms, I guess you could say, right? Not that I want to go into like combining like terms, it's a totally different idea, but right now they're not modeling the same situation. This one's saying they're not important, this one's saying it is important. So it's just like I'm measuring it differently, so this is definitely not going to work out. Just to show you, it doesn't always make a huge difference as far as whether you say it is or isn't. If it's a situation like this, where it's like, really, does the order matter? No. But could you have counted up the arrangements like we did with computer-generated numbers in 9.6? Yes, and it would have been fine as well. Either way, I do get that final, ooh, I definitely just hit the wrong button. Hold on, I'm so sorry. Alt, that's what I want. Nope, that's not it either. Oh, it's the window key. Got it. Cool. Either way, I end up with the same number. But guys, what is that as a percent? What would that be as a percent? Yeah, and that just depends on how many decimals they want, right? But good, we could say like 0.877%. Just making sure that we remember, how do we go from a decimal to a percentage? You guys said it last week. Two to the right. Or, Natalie, you said it this way, multiply by 100, and then you got it. Okay. So that was just kind of not even necessarily using this whole and idea. We could have used the and idea also. I just went straight to combinations and permutations just for you guys to know there was a way of saying, like, what if you chose... let's see, a number less than 5, and then another number less than 5, and then another number less than 5. Then we could say 20 times 20 times 20. Would that be right? So I could almost think about it as in like 5 out of 20 times 5 out of 20 times 5 out of 20. Why aren't these counting down? What did they not say was a big deal or something I had to keep track of? Do you guys remember what makes the counting count down?
If you're taking one out.
Yeah, if you're saying like one is disqualified once it's used, but what would they have needed to say for it to be like 543 in 2019-18?
Not equal to.
It says equal to. What would have made it count down? What would have made this number not be able to be used there or there?
Exclamation mark.
Use the same code twice.
Yeah, if it says that the computer won't choose the same number twice, like it doesn't repeat any numbers. If no numbers were repeated when they were generating, then it would count down. And you're right, it would be a permutation, things like that, but this is also another way of thinking about 5 over 20 times 5 over 20 times 5 over 20. And that would kind of be this idea of and. Or. You guys already wrote this down, so let's talk about or. If I was, let's see, didn't we talk about cards at the end of the week, right? Okay. So what if I was to ask you some sort of just basic example of the probability when when choosing one card, so we'll just say you're picking one card out of a standard deck, of choosing, let's see, a heart or a face card. Okay, of choosing a heart or a face card. So I could like name this like event A, I could name this event B, but in this situation, guys, what is my condition A or my condition B? Condition A is I need to get it to be a what? Or consider how many hearts I have available, right? And then condition B is, what do I mean by a face card? People that know cards, help me out.
Jack, Queen, King.
Jack, Queen, King. Good. So how many hearts do I have?
13.
But what are those? So I have like 2, 3, 4, 5, 6, 7, 8, 9, 10. What else is not a face card?
Ace.
Ace. Okay, so all those aren't face cards. But what would need to go in here? The Jack, the Queen, and the King. But what else would be in the face card category?
Those spades, clubs, and diamonds.
Yeah, so I'd have the Jack, Queen, King. Oops, I guess I need a comma there. Of one of the black suits and the Jack, Queen, King of the other black suit. And then I would have the Jack, Queen, King of the other red suit, right?
Yeah.
So, why am I showing you this picture if I'm about to say that something with an or, which is technically union, U for union, is as easy as P of A plus P of B. Why am I going to actually be like, oh, stink, hold on, look at that picture. That's not necessarily always all I need to think about. I'm going to squish it all in to make it a little bit smaller. Bless you, bless you. I'm going to put a minus. Question. What's the probability of picking a heart out of a standard deck, guys? 25%, 1/4, or 13 out of 52. Is that cool? 13 cards, just keeping it super basic. 13 hearts out of 52 cards. How many face cards are there? 3 per suit, 4 suits, so 12.
12 and then minus 3.
Ah, why are you subtracting, Joey?
Because you have 3 of the same cards. So you don't.
We have to subtract the probability of A and B. If I were to add up all of these guys, which are 13, and if I was to add up all of these guys, which is 12, what did I just double count? You see it? So in harder situations, if I have all of these guys, and if there is what we would call an overlap, I can't just take the total and add the 2, because I have to think about, oh, stink, I just added those twice. Now this is for counting, it also works for probability. Now I know that you're like, well, I already knew that there were 13 hearts and then 3 of those are face cards, so maybe you would have known just to do 13 plus 9. But in harder situations, you might not make that call appropriately. So we have our labeling from up above, our probability of a heart, plus our probability of a face card, minus our probability of, what about those hearts that are also face cards? And if you're like, what's that weird thing she's drawing? Remember, it was from over here. It means intersection, and it's talking about the overlap, where both are true. Is that cool? Oh, coming back. But when do we not have to worry about that? Can anybody give me, can anybody give me like a situation where there wouldn't be an overlap? Like it's impossible for these two things to be true at the same time. It could be cards or it could be something else.
Red marbles and blue marbles.
Yeah, we could do something like that. So we could say that A, although, have any of you guys seen those really cool marbles that have like the different colors like going on?
Multiple colors.
So I wouldn't like that one as much because you might have some like multiple colored marbles. But you're right. Usually that's going to be totally distinct. What'd you say, Joey?
I said big marbles are just the way to go. Not like normal ones.
Two things that cannot be true at the same time. Noah.
That is interesting.
Oh. Can you think of something with cards though? Two conditions that couldn't possibly be true at the same time.
Like events that don't have anything to do with each other. Like something totally different.
Right. We can do it with cards.
Dice and coin.
Yeah, we could do dice and coins. Or spades and hearts. So if we were to keep it like with cards. But yeah, you're right. Like dice and coins would be two totally separate things as opposed to marbles and colors that could be mixed. Yeah. Yeah. But we'll keep it in cards. Go ahead, Noah. What'd you say, Ryan? Spades and...
Spades and hearts.
Yeah. So that'd be an example of what we call mutually exclusive events in that you can't have a spade heart. As you start by talking about wilds and you're playing a different game. But spades and hearts, I'll have my 13 spades, I'll have my 13 hearts, right? And so if I want the or, I don't need to worry about that weirdness because there is no overlap. So all I have to do is think of, well, how many there? Or how many there? And so in this example, yeah, if you were to ask someone to pick a number like 1 to 999, what's the probability that they choose a 2-digit or a 3-digit? You could do something like that. That'd be an interesting question, though. Actually, probably more interesting than what I'm about to show on the next slide, so maybe I'll change the next slide. Let's see, this would be spades or hearts. And all I'd have to do is my 13 out of 52 plus 13 out of 52. Otherwise known as, isn't that half the deck, guys? 2 out of the 4 suits. So we can just say 50%. Yeah. So let's go ahead and talk about that interesting example that Ryan just brought up. And actually it's going to perfectly segue into that last, because this one was going to be kind of boring. Well, we can still do it. Can you guys do the really boring one on your own real fast? Go ahead. Do the really boring one on your own real fast. Go all the way to a percentage. So I'm going to calculate that myself as well. Huh? No. So we'll just say 52 cards. Excellent question. What's a game that does include jokers? Oh,
Wait,
the flipping ones.
are diamonds red
Not
as
all
well?
of them. Huh?
Diamonds are ace diamonds.
Diamonds.
You count the ace.
Look, is that times?
Yeah.
Like
26 over 52 plus 4 over 53 minus 2 over 50.
Wait, there's 13.
Equal to 4.
Why is it?
It was supposed to be 5.
Yeah, but there's 2
There's
seats
2
that
red
are
ones
red.
and 2 black ones.
Really?
You
Yeah,
don't use
there's
a
13
shirt.
is 10, and then the 3 pink.
But it's
So it's 26 red. Yeah. It's like blue. Black from. It's red and black. But like, I mean, they can change it. Exactly. Like, it's technically red.
4 out of
26. But
wait, let me talk to
So I'm going to solve.
what is it?
53.
So
It's 1 over 2.
Or 4 8.
But actually,
Yeah.
it's right.
Yeah, no.
26 over 52.
There's like diamonds.
Plus 2
Yeah, yeah. Oh, you do?
I'm talking about
Yeah.
Brooks.
That's good.
Once you put it in your
Bro.
calculator, once you divide the percentage, 54 is your balance.
So,
Oh.
26 red,
Yeah.
4 ace,
Yeah, but then
plus
there's a
4,
there's
and then
There's 2.
wait. Oh, because but there's 2 8s.
Around it,
We can make 2.
3.8.
divide by
Oh, that makes sense. I don't know where you got 3. I thought it was 180. I'm thinking like it's just Spain. Wait, so what's this?
Well, you haven't. You used to contact at least 3 documents. Or. What do you mean?
Still,
Well, it wasn't as big. That's what else actually said. You don't have it for because even most people around.
no, I have them Monday and Friday and Saturday. Are they both moms? Yeah.
All right, guys, how many red cards? Ryan, I'm coming back to you in just 1 second.
26.
So 26 out of 52, or is telling me to do what? Or is just going to be a good old-fashioned addition. How many aces?
4 out of 52.
But then you have to ask yourself the question, but are there any exactly red aces? How many are there?
2.
Oops, there we go.
2.
So you end up with 28 out of 52, which you guys should have gone ahead and made into, because I just wanted you to practice it. What's the percentage?
53.8.
Oh, wait.
4.6%.
53 point what?
8.46%.
Oh, 846?
8.46%.
Okay, but let's go to Ryan's question. He mentioned like a 2-digit number and a 3-digit number. Ready? What if I was to ask you for scene? Hold on, we gotta set the scene. The scene is you're choosing a number. Girls, ready? This one's gonna be exciting. Not that exciting, but kind of. Choosing a number from, here's the range, 1 to 999. Ooh, let's go to 1,000. Who would actually say 999? Do 1 to 1,000. And then we're asking, what is the probability that you're choosing a 2-digit or 3-digit number? What's the probability? I'm trying to find the most efficient way to solve this. What's the most efficient way of solving this?
So that's all of 1,000. So 1,000.
Why are they subtracting things back there? I thought you had to add up and then do the or and then
Isn't there just 92? Starts at 10.
Minus 9. No, because 990 over 1,000.
10, right? You have 9.
You guys can check what you're thinking and see if it matches up. Check what you're thinking, see if it matches up.
So,
Wait,
okay.
right. Yeah, I'll check. So
Minus
you said 990. 990.
Just subtract.
No.
But we started at 1.
So you subtract.
Oh, I made it messier than it had to be. It's 99%.
It's 2 digits.
Okay, you do it.
Yeah, it's just
99 minus 9.
I did 80.
I thought you'd have to do however many 2-digit numbers there are. Because that would be all the numbers from what, 10 to 99?
Oh, yeah, 9. 4, 5, 6, 7, 8, 9.
And then 3-digit numbers, that'd be 100.
That's why did it subtract 10?
I was just thinking subtract.
4 letters.
Wait, then it'd be 11.
No, but if you just do 10,
So it'd be 89.
right?
Oh,
It's just
what
10.
did you provide?
89. 1,000. I did not think of that.
800. I get it.
Which one looks easier? Your classmates have been talking about subtracting, but this subtracting is a bit different than the taking away where they're both. Because can you have 2-digit and 3-digit at the same time?
No.
No. So your classmates who are subtracting, they're not subtracting because of an overlap. Why are they subtracting?
Just to figure out how many 2 digits.
So you have to get rid of the single digits or the
They're thinking, what? Well, but figuring out how many numbers here and how many numbers here, they're going to have to be getting like these things, right? So how many numbers are between 10 and 99? 89 or is it 90? 89? Why would it be 90? I mean, you subtract and it's 89, right?
The first 9 numbers go.
Because they're not at the end.
The first 9 numbers,
No.
I also have the 0, yeah. Remember how 1 to 9 is 9 numbers, but 0 to 9 is 10 numbers? Remember that? So if I subtract 89 numbers, it's kind of like what's between. It's not including 10, it's including 11 all the way to 99, but I need to include the 10 also. But that's tricky, yeah? So hold on, you guys tell me how many numbers are between 100 and 999, including those 2 numbers? No? No? 900. It's 899 plus 1. It's 899 plus 1, because it's ending in a 0 and not ending in a 1. But this is tricky, right? Like, ew, gross. Those of you that were subtracting, they were doing the creative route. Not that you couldn't have subtracted and then added 1, subtracted and then added 1. You would have gotten your 990. But what was going on here, my kids that were doing this? There were quite a few of you that naturally thought of that. What were you doing?
I actually did 99 plus 990.
Oh, that's funny.
So you count the zero?
Yes, well, you have to count the 10, and you have to count the 100, and that's like the 0. That's like the 0, yeah. But hold on, what were the kids doing that were doing this? Brendan, you were talking about this.
Taking all numbers and then just taking away that numbers that were
Exactly.
Taking away this first line, and then
Which ones don't work? Do you guys realize there were a lot fewer that didn't work than did work? Most of the numbers were 2-digit or 3-digit, so what numbers aren't either of those?
79 and 1,000.
Yes. You have 1 through 9 and 1,000. Because 1,000 is a 4-digit number, and 1 through 9. I have 9, I have 10 numbers, which was a lot easier to count. I have 10 numbers that didn't work. So from 1 to 1,000, I'm not starting at 0, I'm starting at 1. There are 1,000 numbers here. But if I take away 10, I know that it's 990 without having to do all that weird like mental gymnastics of figuring out how many numbers are included in 10 to 99, how many numbers are included in 100 to 999. I can just say, well, I know which ones don't work, so then take those away, and yay, I divide. Dun, 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 dun. This is actually very mathematical, and it's called considering the complement. The chances of something not happening, or the number of ways something doesn't work. Oh, I need batteries. Sad day. Good thing class is almost done. Figuring out the number of ways something doesn't work. So let's put some vocab to it, and then we've got it. What some of you just naturally did, and maybe it was laziness, maybe it was efficiency. It's kind of hard to tell the difference sometimes if you're productive in the midst of your shortcuts. What's street smarts? What are we talking about? Anyway. Logic? Common sense? Not so common. To consider the complement. Here's the notation. The probability of not A. I'm just using A as the name of an event. Do you guys want me to use E for event? I don't, does it matter? It's okay. The notation for it is, some people do it different ways. The most common one I've seen is the little, is it tilde or tilde? Tilde?
What is
Tilde.
Tilde, thank you. But that's not the only way. Some books also do this weird, like, little, like, other symbol in front. Other books might do, like, an A prime. Just keep an eye open on WebAssign. I'll ask you guys about it as you go through homework to see if they have another way of showing it. But it's basically just something to show. It's not A, it's like the other stuff going on. It's the not. It's the negation is a better way of thinking about it. So if I was trying to find the probability of not A, using my notation, what I'm used to, I could do 1 minus probability of A. Or similarly, I could say the probability of A happening could be 1 minus the probability of it not happening, which is what the guys just figured out with, instead of counting up all of these and getting confused, they just said, 10 numbers don't work, sweet, it's 990 divided by 1,000, which got them that percentage. So this can actually work either way. And algebraically, we could easily prove that by adding this to the other side, subtracting that. But guys, can you remind me real fast, what happens if the probability of something happening is 1? What does 1 stand for in probability again?
100%.
There you go. So we're saying we would have to subtract all the ways out of the 100% options, like out of the total favorable total outcome, sample space of outcomes. I'm saying what's left or what's left. And here's a great example for that. When you guys are ready. Here's a great example for that when you guys are ready. So those of you that were doing it the hard way with the numbers 1 to 1,000, read this example and try to think, sometimes it's easier to count what's not working than to count what would work. As you guys are pondering this, let me just give you like a quick little note. I'm not solving it. I'm just having you guys start thinking about what you need. How does 1 over 1,000 raised to the 200th power give me the probability that all 200 that you order would be faulty? It's a very slim chance. Because 999 out of 1,000 work. Where does this come from? You get your first one. Faulty or not faulty? If they're all faulty.
They're all faulty.
Yes, if they're all faulty, is this one faulty or not faulty?
Faulty.
Faulty. And what is the probability of it being faulty? 1 out of 1,000 is faulty. So not faulty or working, what would be the odds of that happening? Or I should say the probability for 1. Yeah. That's pretty good odds, right? As far as like a company's success rate for shipping 1 or for testing 1 out of 1,000. But if they're all faulty, then guys, this one falls into the 1 out of 1,000 range, right? What about the second box that you open? It doesn't work either. What was 1 out of 1,000? Well, what about the third box you open? Well, it doesn't work either. 1 out of 1,000. Question, how many did you order?
200.
You see it? That's how this one comes about. Every single box that you open. Why would it be times? Because you got a shipment of 200, so you're opening the first box and the second box and the third box and the. I just summarized it.
The machine has to be the Sandy broken.
This is not the correct answer, but what is it?
Less than 100%, close.
It is, yes.
Why am I going to label this the complement? If I can spell complement. What are they asking me for the probability of?
But then not occurring.
What is the possibility?
Oh, they're asking for 1 or more. So question, is this a part of the actual like adding up? 1 or more. 200 is more than 1, right? So 200, 199, 198, 197, 196, 195. We would have to figure out all these different cases. Hold on. What is the complement? It's not this one. That's not the complement, because this is actually a part of getting one or more faulty units. It's like the worst case scenario, all 200 are bad. What's the complement, guys?
1 minus 1,000.
Probability of getting all what?
All faulty.
No, because this is figuring out faulty. All what?
Good.
All good. That would be the complement. So I could do 1 minus the probability of all good. But wait a minute. Can you use what I showed you for all faulty to help me find all good? What would that be?
999.
It's that. It's 1 minus that.
No, 1 minus that would be the probability of not getting all bad.
It would be 999 over 1,000 to the power of 200.
Each one, instead of being bad every single time, what was it every single time? Good. You would think you'd have really good chances of having all be good, right? But what happens when you do 999 divided by 100 or by 1,000? 0.999 raised to the 200th power. What do you get? 81 point. Is it still not too bad?
Oh, dang.
It's not too bad, but then again, not as high as I thought it would have been. Muy interesante. Maybe we'll talk next time as you guys are asking WebAssign questions how hard it would have been to count it up the normal way. But that complement can save you, oh my goodness, 1 to 200 faulty units ways of counting up.
So the faulty would go on top and the 200 would go on the bottom? Or is it opposite?
Faulty. Sample space, so, well, I just used the probability, right? Yeah, I was just using the probability and plugging it in. So I wasn't really doing a sample space situation. Alright, work on your WebAssign, cool kids, and I'll see you next time with homework questions. Otherwise, see you in the gym for Justice Day 1.